All right, so here we are now at one example that shows how we can apply the skill in taking antiderivative, or specifically the skill in taking indefinite integral into business field. Okay, so let's spend some time reading the description of our problem here. So suppose that the monthly marginal cost for smoke jumper harness straps is so AMC with the bar here is the symbol for marginal cost function. And so that is given here to be 2.5x plus 110. And so x here, this problem is actually missing the explanation of the variable, but x here represents the number of units being produced here, because now we're talking about the cost. So marginal cost as a function is 2.5x plus 110. And the production of 11 units results in a total cost of $1,646.25. So, question in part A is asking find the total cost function. Okay, total cost function. And so now that means right here, extracting the wording out of problem part A, then we want to find C of x, the total cost function. That's what now for us, the math students who are on track for business the applications out there, then we are well familiar with the way how commonly a lot of math textbooks in your major notate cost function. So capital C here is the function for cost. But so now if we're looking back at the description of our problem, then what we have here given information is the marginal cost. Okay, so this 2.5x plus 110 right here is our marginal cost for clear. And so in that way we already knew that our C prime of x, because see, in my other video lectures, and here I can briefly mention as well, derivative is the marginal cost of, the C prime of x is the marginal cost of C right here, the marginal cost function. So now we knew that derivative of C is 2.5x plus 110. So we know that marginal cost is 2.5x plus 110. So we put ourselves in that scenario where, hey, for whatever reason that is, we actually notice the change, the rate of change, the general rate of change of our cost for our company. Okay, so what a useful information. Because what can we do with this marginal cost function? The question in part A wants us to find the total cost function. So the relationship between total cost and marginal cost now is that marginal cost is, as you already know, the derivative of the cost function. So to find the cost function, from there I am going to take the indefinite integral, or just for short the integral of our marginal revenue function. So 2.5x plus 110 as our marginal cost function. I am going to take the integral in respect to the x variable right here as for units. And so now with that we are looking at, so all that skills you have learned in my lecture, in the lecture about finding antiderivatives or finding indefinite integral, then this is going to give us 2.5 times 1/2 x squared, and then I'm going to add, maybe let me rewrite that to save a little more space right here. So 2.5 times 1/2 x squared, and then plus, and then the sum rule says we can go 110 x and plus c. And so now at the end, and I have to clarify a little bit. So for business students, we usually use a capital C letter for cost function. So how about let's be a little more clever here. I'm going to say, actually I should, plus k, how's that, for a constant, so that we don't have to overlap with the that C here that's reserved in our business application for the cost function. Okay, so in the end, it's 2.5 over 2 x squared plus 110x plus a constant k, an unknown constant k for now. But that is at least our general cost function. And this is our total cost function. Okay, but now see, we're not at the end of our question part A yet, because we need to find out what that the constant k is, because the question itself is looking for find the total cost function. But we need to know what that is, because the way how we have our answer right now, there can be so many different functions. Because back in the lecture when I was explaining about antiderivative, then this function with a k equals 5 is different with the same function here with a k equals 1000. So in our case here, we need to specifically find out what value of k it needs to happen right here. Okay, so in other words, if you have viewed my video lecture a little more carefully, then I introduced in there the kind of problem where it's so-called the initial value problem. This is one of them. This is one of them. And so here's how I can look for the information. Really, when it says find the total cost function, but we know another piece of information right here. The production of 11 units result in a total cost of $1,646.25. Okay, and so this information that I just now highlighted means that, and maybe I'm a little bit out of space, so let me write on the other board here. It means that when we are producing, when x equals 11, so C of 11 really equals 1646.25. So this is, now if we're trying to make things relevant to our the general lecture regarding antiderivative, then this is referred to as the initial condition right here of our entire problem, which is now can be understood, can be regarded as an IVP, I mean an initial value problem. Okay, and so now in that way, I am going to advance on my other board, and let's continue solving it further. Our C has already been found. Our general solution, C of x, is found to be 2.5 over 2 x squared plus 110 x plus k. So in that way, so now I am going to substitute in. So that means C of 11. This left-hand side of the initial condition must equal 2.5 over 2, or how about let me write it this way. C at 11, the left-hand side can be written as 2.5 over 2 times 11 squared, how's that, plus 110 times 11 plus k. That's the left-hand side, and this is precisely C of 11, our total cost function at production level, the 11 units. And then we want all that. It's stated in the problem. At production of 11 units, we result in a total cost of $1,646.25. Okay? And so now we produce for ourselves an equation to solve like that. Okay, and so we can just take some time doing the quick calculation on all this, and then I'll be quickly stepping out for a calculation. And so we are now looking at all that here with my underlined brackets right here is $13.61.25 plus k, and all that there equals $1,646.25. Okay, and so now finding the value for k is just a matter of solving this very basic equation. So K equals, and I'm going to quickly step out for a calculation. So now I'm looking at K equals 285. Okay, and so now that's what K is. And so in that way, now I'm ready for coming back to my total cost function, which answers part A. So this final total cost function, now we can write it as plus 285. Okay, so this is our total cost function. Okay, and so now let's have a look at part B of our current example here. Okay, so now once we have found, because being able to find our total cost function now is so valuable for us, because in part B here we can find the total cost for producing 30 units. Okay, so we want a total cost, but at producing 30 units. So that means with our found C of x function and with a final concluded constant K value right here, then I am going to be able to calculate I should now be able to calculate C at 30. And so according to our final function, the total cost function, it's 2.5 over 2, but times the input variable. So now this time it's 30, so 30 squared plus, and then I had 110 times now 30 substituted for x, and plus 285. Okay, and so now I am going to again step out for a quick calculation for the final value of the total cost. And I now have come to a total cost being 4710. This is all in dollars. So we have a total cost of $4,710 when we're at production the level 30 units. Okay, and so now this is really the end of our current example here, but allow me to introduce a couple other terms right here in case you run into similar problem, but having slightly different wording right here. And so we now have found we have already found our total cost function out of its marginal cost function, or namely its derivative. So we first found a general solution being 2.5 over 2 x squared plus 110x plus k. And then we used our initial condition to solve for, and we came to this particular value. So now, if we're looking at this final total cost function here, strictly in a business point of view, then see, it's a cost. And remind for yourself, cost always come as a total of as a sum of variable cost and fixed cost, because this is total cost. And there are always variable cost, which is the cost that depends on the number of units we're producing. And then there's always a fixed cost. And so now here's another way to understand and interpret these values right here. You see, if you're looking right here at your final total cost function, then that part right here, before the constant that we have found, that part before the constant we have found, maybe I put my red brackets a little too far right here, but see, just right before adding that constant right here. Okay, then that part right there is ladies and gentlemen. In a different language, we call it, it's a variable cost. Because look at the way how it is. It will produce different amount of cost depending on what production level we're at. Okay, so that's variable cost because it depends on the number of units being produced. But this doesn't matter what number of units you are producing. Your variable cost there will always be added to this constant. That's what it's called in math. It's constant 285. So this is right here in the business concept. It's particularly when we're seeing this as part of a total cost function. And that's K right there. Or this 285 we found in this problem is called a fixed cost. That's how it is. So in many other problems, for example, then maybe the problem say, instead of saying, at production level 11, see, instead of, like say for this problem right here, let me bring up the wording again. Back in the same description of the wording is here. Let's just read the wording of the beginning description here. But see, in the wording of our problem here currently says at production level of 11 units, or the production of 11 units result in a total cost of 1,646.25 cents. But see, that's just the wording in this problem, but the exact same problem, but maybe some other time other author might word the problem as saying that someone can say that the same way of wording, but it says given that fixed cost is fixed cost is 285. You see what I'm saying? Okay, and so that means so here we don't even have to worry about that as x equals 0 or not. But we're talking about after we solved it, we already come boom right there. It's already gave us easily a solved value for that k value. Okay, so that's just the way how we see that constant in our antiderivative work in the concept of in the business concept there. Okay, and that's what I want to address, and I want to finalize in case, right outside of this example where, the way how it's worded this way that I introduced, but you might see some other kind of problem exactly the same, but unfortunately being worded a little slightly different, and you might feel a little unprepared for that. But that's how it's worded a lot of times. Okay.